This video is about equations of lines and planes in three-dimensional space. Let's start with lines in three-dimensional space. The line L passing through point P0 with coordinates x0, y0, z0 and parallel to the vector v with components ABC has parametric equations x equals x0 plus at, y equals y0 plus bt, z equals z0 plus ct, where t is the parameter. This means that to determine a line in three-dimensional space, we need two things. We need a point P0 on the line and a vector v which is parallel to that line. Let's see an example. Find parametric equations of the line through the point with coordinates -1, 4, 7 and parallel to the vector with components 3, -2, 7. We have everything we need. We have a point on the line and a vector parallel to that line. So we're ready to write the parametric equations. Recall that the parametric equations are given by the following three equations. So x, let me rewrite them again. X equals x0 plus at, y equals y0 plus bt, z equals z0 plus ct. T, a real number, is our parameter. So x0, y0, z0, and a, b, c. So it's just a matter of plugging things in. X equals x0, which is -1, plus at, which is 3t. Y equals y0, which is 4, plus bt, that's -2t. And z equals z0, which is 7 plus 7t. T is the parameter. These are parametric equations of the line through the given point and parallel to the given vector. Here's a slightly more challenging problem. Find parametric equations of the line through points A with coordinates 4, 4, 2 and B with coordinates 5, 3, 2. We have 2 points on the line, but we don't have a parallel vector given to us explicitly. But we can make use of the 2 points to come up with the parallel vector, like so. The vector AB has components 5 minus 4, 3 minus 4, and 2 minus 2. So the vector AB has components 1, -1, 0. And this vector is parallel to the line L. So AB is parallel to the line L. This means A is 1, B is -1, and C is 0. These are the components of the parallel vector. Now instead of 1 point, we have 2 points on the line, so we get a choice. We can choose either point A or point B and plug them into the parametric equations. Let's say we pick point A. So we have x0 is 4, y0 is 4, and z0 is 2. Let me remind you of the parametric equations of a line again. X equals x0 plus at, y equals y0 plus bt, z equals z0 plus ct. T is a number, that ranges from minus infinity to infinity. Now we plug everything in. X equals x0, that's 4, plus at, that's 1 times t, that's 4 plus t. Y equals y0, which is 4, plus bt, that's plus minus 1 times t, so that's minus t. And z equals z0, which is 2, plus ct, that's 0 times t, so that's just 0. These are parametric equations of the line through points A and B. Now let's talk about planes in R3. To find an equation of a plane in R3, we need two things. We need a point P0 in the plane, and we need a vector n that is orthogonal to the plane. We call that the normal vector. This is illustrated in the picture on the screen. An equation of the plane P through point P0 whose coordinates x0, y0, z0 with normal vector n whose components are a, b, c is given by a times x minus x0 plus b times y minus y0 plus c times z minus z0. Of course, this equation can be expanded, can be written as ax plus by plus cz equals d, where d is ax0 plus by0 plus cz0. Let's start with a simple example. Find an equation of the plane P through the point A with coordinates 1, 6, 0 with normal vector n whose components are 3, 4, 8. This is a simple example because we are given exactly what we need to write the equation or to write an equation of the plane P. Recall the equation is A times x minus x0 plus b times y minus y0 plus c times z minus z0. So 1 is x0, 6 is y0, and 0 is z0. Also, a is 3, b is 4, and c is 8. Let's write the equation, or write the equation of the plane in R3. That is a x minus x0 plus b y minus y0 plus c z minus z0 equals 0. That's 3x minus 1 plus 4 times y minus 6 plus 8 times z minus 0, all equals 0. Let's go further and expand this equation. 3x minus 3 plus 4y minus 24 plus 8z minus 0 all equals 0. That's 3x plus 4y plus 8z minus 27 equals 0. And finally, we can write it as 3x plus 4y plus 8z equals 27. That's an equation of the plane through point A with normal vector n. A more interesting example, find an equation of the plane P through points A, whose coordinates are 3, 1, 5, B with coordinates 0, minus 1, minus 3, and C with coordinates 0, 1, 8. We have 3 points sitting in the plane, but we're not given the normal vector explicitly. and that's a crucial component to find an equation of the plane P. So we start out by writing the vector AB, which has components 0, minus 3, that's minus 3, minus 1, minus 1, that's minus 2, and minus 3, minus 5, that is minus 8. Let's also find the vector AC. This has components 0, minus 3, which is minus 3, 1, minus 1, which is 0, and 8 minus 5, which is 3. Now those two vectors, AB and AC, are sitting in the plane. If I cross these two vectors, I get a vector that is orthogonal to my plane. And this can serve as our normal vector. So, AB cross AC is orthogonal to the plane P. Let's find AB cross AC. This is the 3 by 3 determinant, whose first row is IJ. Okay? The second row consists of the components of AB, that's minus 3, minus 2, minus 8. And the third row consists of the components of AC, minus 3, 0, 3. That's equal to minus 2 times 3, that's minus 6, minus 8 times 0, that's 0, minus 3 times 3, that's minus 9, minus 8 times minus 3, that's plus 24. All multiplied by j, plus minus 3 times 0, that's 0, minus 2 times minus 3, that's plus 6, all multiplied by k. So our normal vector has components minus 6, minus 9, minus 24, that's minus 33, times minus 1, that's plus 33. And 0 minus 6 is minus 6. So we have the normal vector AB cross AC has components minus 6, 33, and minus 6. So A is minus 6, B is 33, and C is minus 6. We also have a choice of 3 points to pick as our point in the plane P. We can pick point A or point B or point C. If we pick point A, we get that x0 is 3, y0 is 1, and z0 is 5. So, an equation of the desired plane is ax minus x0 plus b times y minus y0 plus c times z minus z0 all equals 0. A is minus 6 and x0 is 3. Minus 6, x minus 3. B is 33 and y0 is 1 plus 33 y minus 1, and C is minus 6 and z0 is 5. Minus 6 z minus 5 equals 0. Let's expand. Minus 6 plus 18 plus 33 y minus 33 minus 6z plus 30 equals 0. That's minus 6x plus 33y minus 6z minus 3 plus 18, that's plus 15 equals 0. That's equivalent to minus 6x plus 33y minus 6z equals minus 15. Or more pleasantly, if you multiply the whole equation by negative 1, we get 6x minus 33y plus 6z equals 15. That is an equation of the plane through the points A, B, and C.